I might start and draw the front of the cube first. I might then try to take it into the third dimension by doing this. And then I would complete the cube. And then if I want to show depth in the cube, I might put a dotted line like this. And now I can see the depth of the cube. Does that make sense, drafting? So drafting was the original way to design things. There was no CAD. So people would draft things, right? And then they would build them. They would build a prototype from the draft. Or they would draft buildings. And then the building would be constructed based on the draft. Drafting is great, but with computers nowadays, in CAD, you get so much more out of your design if it's on the computer. Because if it's on a computer and I've designed it, I can now apply a force right here and see the result of that force. Is it going to cause the object to break? Is it going to cause the object to bend? Is it going to cause it to twist? Is it going to cause it to slide to the left, slide to the right? So you can apply forces to objects and see the result of them. So if I had a design of a bridge, I'd probably want to put forces all over the bridge, which are cars. The cars are forces acting down. So with a computer, you get more out of it. But I'm going to start you today with the concept of drafting because this is really where it all began. You wouldn't learn about multiplication before you learn addition. Because multiplication is actually a form of addition. Right? 7 plus 7 plus 7 plus 7 is really 7 times 4. That's the idea. Same concept here. So we're going to talk about two different terms. Isometric and orthographic. Isometric and orthographic. So again, remember I talked about there could be quizzes? It's the kind of thing where there could possibly be a quiz next week on this kind of an idea. So let's take a look at the first slide. So the first term we're going to look at is called isometric. And isometric is what you see if you're looking right at an object. And what I mean is this. If I have the object here in 3D space, if I were to rotate this thing like this is an isometric view of it. I can see the third dimension. Isometric shows you depth, shows a third dimension. And you can see that here with this image. With isometric views, we could look at it from the top, we could look at it from the front, we could look at it from the side, and there's also bottom, back, and then left side instead of right. But these are the three views, 3 dimensions, 3 views. Front, top, and side. Front, top, and side. So isometrically though, we see the whole solid. Orthographically, go to the next slide. Orthographically, we only see one face of that solid. For example, if I were to, I'll use this I guess, yeah. If I were to look at this eraser, from the front, you guys see a rectangle. From the, sorry, this would be the side. From the side, you see a rectangle looking in this way. From the front, you see another rectangle. From the top, you see another rectangle. So the orthographic views of this solid would be 3 rectangles. That's all it would be. This is what an orthographic view looks like. So here's the solid right here. If I were to get right in front of it and take a picture where the light rays are coming out of the camera, parallel to each other and perpendicular to the front, this is what you would see. You would literally see that image. Yet, when I look at the isometric image, I see the third dimension. But the orthographic view shows only 2 dimensions. So the orthographic view is a 2-dimensional picture of one of the 3 faces, top, front, or side. Top, front, or side. We can see that more clearly on the next slide. Let's take a look at that next slide. So we've got orthographic on the left, and we've got isometric on the right. And this is the same object. It is the same object, shown with 2 different perspectives. And think about it for a moment. If you were to look from the front, I need you guys to really, the tough part about this course is visualization. Maybe I'll do something with another sheet. So all right here. All right, this is not ideal either. So, I need you guys to be recognizing that in this course, you have to visualize things in your mind because the page doesn't show the third dimension. Yeah, it shows it, but you can't physically touch it. So when you think about this, this is what you're looking at. Here's the front. So So if you looked at this solid from the front, you would see a little rectangle, you would see another rectangle, and you would see this little sliver of a rectangle. That's this right here. So if you're looking at it from this perspective, that's what you would actually see. If I took a camera and took a picture from the side directly at it, I would see exactly that from the front side. From the side over here, again, from the side, now I'm looking in like this. And from the side, I would see what looks like a little staircase. Right? So there's like a little step right there. And take a look. There's that little step right there. But behind that step, if I look, I see this shape. And that's right here. So this is right there, and then the rectangle is the bottom. You know what? Let me use a color coding system to help us. It may be very obvious to some, it may not be to others. So if you're like, this is so easy, I totally see it, that's good. But not everybody sees this kind of stuff. So you might have a spatial mind where others don't. So I am going a little bit slow with it, but bear with me, please. So from the front perspective, so we can see what I'm referring to, if I mark this as red, that's this right here in red. That's the front view that we're looking at. Now mark the next piece in blue. That rectangle's in blue, that's right here. And then finally, the last part is this rectangle right here. And they may be squares, but I don't know that they're the same size, so it looks like a square, the one I just shaded in yellow, but I'm calling it a rectangle. Okay, again, I'm calling that a rectangle because I do not know that it's a square. It has to have the same length to be a square. So that's the front view where you can see the association of the colors. Is that clear? Does that make sense? Does anyone have any questions so far? Okay, all right. Side view we went over, that's from here. And then top view. Top view. If I look from the top, I see a rectangle here, another rectangle here, and another rectangle here with kind of like a little, it looks like a little edge kind of notched out. There's that little notch right there. This rectangle is this. This rectangle here is this. And this bigger rectangle with the notch, like two rectangles, is this piece right here with a little bit of depth. Okay, so again, we've got isometric is the 3D solid, orthographic is a projection, let's write that word down. Orthographic is a projection of each face. Now, obviously, in this case, we're looking at only 3 of the faces of the solid. Any solid has technically 6 faces to it. Because you have front, in this case, side, top. But then with front, you also have back. With side 1, you have side 2. With top, you also have bottom. So really, there are 6 viewpoints you can take for any solid. Even if the solid is not a rectangle, the solid can be a triangular prism. But you generally have 6 viewpoints. For orthographic views, though, you look at only these 3. Top, front, side. Top, front, side. All right, with that said, let's get into the actual notes so we can do a little practice work. Now that you have the ideas. So we're going to look at one together first, and I'm going to progress through these slides. This is the front view. This is the top view. So based on those 2 shapes alone, what should the solid turn it to look like? And we'll do the first one together, so just go to the next slide. That's what it looked like a minute ago. We'll see, okay, you know what? This is the front view. So a moment ago, we didn't have all this stuff. Let me go back so you can see that again. And then what we see is the progression of the shape taking place. And then on the next slide, we see the rest of the shape taking place in the back. And see the dimensions? This dimension was W, right? There's W right there. This dimension is H. That's the height right there. This dimension is called D for the front. That's D right there. So this is the depth, that's the width, and this is the height. This height is the same as this height, which is why this rectangle's height is the same as this one. They both have the same physical height. So on the last one, we can step to see what the general shape. This is just a brick. Yeah. This is just a brick. That's all it is, right? A 3D rectangular prism. A 3D rectangular prism. Remind me, I'll talk about the word prism later, actually, when we get into CAD one. Okay, so that's the first one. Now, here's what I want you to do. With the view, work on the second one. Okay, with the person next to you, you can try yourself, and then the person next to you tries it, and then you compare. So try to get an idea of what you think this would look like if this was the front view, and that was the top view. Again, no side views needed for this one. So think about, and this is not easy to do, I know. So maybe go back a couple slides and remind yourself what the front view means, what the top view means. You're welcome to talk because you're going to be working with the person next to you. I'll give you guys a couple minutes to look at this one first. The next one's going to get a little trickier after this. Here we go. If you want to work with that, move over. That doesn't mean you're just going to copy what she's doing, all right? Okay.
I actually know what I'm doing.
You probably want to open your iPad and do this one.
Yeah.
It would be useful.
I thought it was one copy per.
No. You're each doing it, and then you're comparing and contrasting.
Inevitability.
Great. Yeah. Awesome job, man. Really good. Again, you should be comparing with the person next to you, but don't just look at their answer. Make sure that they get their work done, and then you talk about it.
So, Mr. House.
Go ahead. Yeah.
Am I the wrong one?
I don't have my Apple Pencil. Can I just connect the lines like this? Is that fine? Yeah.
Give me the pencil. Again.
That's definitely good. Yeah. You're drawing the side view. Yeah.
And don't worry if you and your partner differ. That's fine right now. You can have different opinions.
All in combined.
This is an unrelated topic, but anybody have trouble logging into the laptop when they came in? Did anyone not log in? I just want to know. Everybody was able to log into the laptop? But it didn't work, function? Okay. All right, who wants to airplay their object? Who wants to airplay their object on the board? Somebody else. I'm not going to put the answer up right away. Who wants to airplay theirs? Go for it, yeah. It's under physics now. It's probably a prompt from the code or something. Your screen mirroring, and it goes 35370.
I'm still stuck on this.
That's all right. So we're going to look at somebody else and we get an idea. Who tried to steal it?
And G.
Sam.
Oh.
All right. Nice, guy. You can steal it and you can do that. All right, we'll look at yours and we're going back. We're going to the power back. So unfortunately, I think yours was a better solution to show you. Sam, you have the right idea, but let me point something out. Exactly. When you look at the shape from this way, see the angles? This would have to be flipped around. Follow? All right, steal it back ahead. I didn't know you could take it when somebody else is on it already. Yeah. So, let's take a look at the shape. Now, what do we notice? What do we notice? We have right angles. Take a look. We have right angles everywhere. So this is pretty darn good. Now, for the most part though, it's odd. The only thing I would change maybe is this line is straight up and down. Maybe this one a little bit straighter to show the angle. But this is the general shape. We see a rectangle here and here. That's this and this. We see this L-looking shape as an L-looking shape. Well done. Very good. So go to the next one. If you did not understand this, again, it just sometimes takes practice. And it's not going to be easy for everybody. Some will see it right away. Others might spend a while looking at it. It's okay. Okay, but look at the next one at this point, please. If you struggled on the first one, you want to look at the progression of that shape. So this is the first look at it. Then we add in the front view here and the side view with that shape. Then we notch out that other piece. And then once that other piece is completely notched out, we see the space missing in the front. And then there's the final shape itself. So this is what you wanted for the first shape. Okay, but a lot of you had similar shapes or similar looking shapes for it. Okay, go to the next one, please.
Straight down. A really small shape. Oh wait, no.
And then expand it.
Yeah, I didn't know that.
Yeah, if you use the selection tool with the little scissor, you can make this larger or smaller. While you're working, I'll talk. When you do come in the future, as soon as you come in, there'll be laptops out every day. You're going to log in right away when you come in. Today, we'll probably not get to use the computer program as much. There's about 10 minutes left or so. So I don't think we'll have time to get started up. But the reason I say you're going to log in right away is because the login sometimes takes a little while. And then once you start the program, it takes like a minute or two to load all the features because it's extremely large files the program runs. So again, when you get in, start it up right away. Like as far as the number dimensionally?
Yeah, like just looking at this.
No, you can't know if this is like 3 centimeters or 2 centimeters. There's no dimensions in anything. So you can
just jump strong.
well, it's strong. You have to recognize that when this says front right here, it means actually you're looking at this. So this shape should really be replicated right over here. And the side is looking in here. So you replicate that over here. And you guys like put it together to figure out what work. It's not easy. I'm making it seem easier on the board, but it's not an easy thing to do.
Oh.
Also, just so you know, when we're using the laptops, we're going to have mice for each one. And the mouse bottom slides open. You take this little sensor out, plug it into a USB port so you have a wireless mouse, and then turn it on. When you're not using it, like this one unfortunately, it should be turned off, please, so it doesn't run battery. So when you come in, I'll get these out of here. This is just the batteries and work for now. So when you come in, the laptops will be there. There'll be a mouse next to it. If you could, just pop it out and plug it in. It's not already in there. I recommend the mouse. So if you're going to come and do this work outside of class, don't do it in the tech center or the module center with a regular laptop and no mouse. Because the mouse has a lot of shortcuts on it. The scroll wheel helps a lot. The touchpad on the keyboard is not very efficient. So if you are going to do work outside of class, you might want to either borrow a mouse, come by, or bring your own in, at least to have one, or just work in this room where you have a mouse right here.
Where do you find these laptops?
Yeah, so that's it. So your laptops for this course are going to be here. This cabinet is traditionally locked. So if you come here, you're free. If I'm not available, you can ask Mr. Joseph or Ms. Myers to open the cabinet for you. Get the key as well. So you can borrow a laptop, work in here. If you're going to work in here, if you're going to borrow a laptop, I'd rather you work in here if the room's open. If the room is being occupied or used by another class, sure, then maybe you can take it down to the library. But if you're in the library already, you can just use the ones in the module center. Those laptops have the exact same program on them. You would just need to either stop by and grab a mouse or just have your own mouse that day. Okay? Alright, can I get an idea for this? Anybody have anything? You want to show me at least? Show me what you got? I can give you little pointers. Anybody have anything drawn they want to see? Keep working on it. You got the general idea, though. You got started.
I think we got something.
A lot of people have the front and the side view kind of down pat. So this line corresponds to this here. This side here corresponds to this here. So you kind of reverse it there.
So I just messed up some I mean, this part is
pretty good so far.
This is part missing more
So top, there's nothing there. So this kind of channel needs to be chopped out.
Well, I thought like this part. That's still.
On the side view, this is what you should be looking at on the side here. So I should see a big looking rectangle, so this should be big. And then next to it, should see another rectangle going on top, but that might have some depth to it. Guys, again, this is not easy by any means. You gotta just try it out and try to draw the shapes. You get the shapes to work. What do you think? There is a hole there, right? So you need a channel down there that's going to carve that out. So I'm guessing that this shape is going to somehow appear back here.
Where does this line?
Hey, the benefit to this is that I might give you like a quiz on it, but after that, we're going to do everything on the computer. So drafting is not really done that much anymore because of the fact that we have CAD programs. But obviously I want you to understand how it works or the ideas. I'll give you a hint. I'll go to step 1 maybe, or step 2 rather. So this is the original, right? I'll give you, your original just looks like that, right? See what I'm saying? It's just giving you the the isometric view, so you see the 3 dimensions. You don't have to draw it right on here, Nico. It might not be useful to draw it directly on here because of the fact that you have this piece. So if you want to, in your Notability slides, I'm sure you have this open in Notability right now, you can maybe even like scroll down and draw yourself a new shape down here and start first maybe with this shape and then put like an arrow, then go to your next shape. You see what I'm doing?
Yeah.
Like the way I'm doing it with the steps, the starting point here. So I could start by drawing that first. And then I can start removing pieces. So I see how I have to look right now? Well now, from the top, I see this channel is not here. So I can then, if I want to, draw a rectangle there and get rid of that channel, remove it. So you could start with a 3D prism. A rectangular prism was to draw just the brick like this, then or the second step, whatever. Then you might want to use Notability pages and just add a page in between and keep adding to the shape. So maybe your first one looks like this. Then you work your way through there. So look at my second step. So my first step was just to draw a brick. Okay, my first step was to draw a brick. Then I took into account the top view only. Only taking into account the top view makes your solid look like that. Again, only taking into account the top view will make your solid look like that. This right here, take a look. This missing piece of the top view is this. Cut out from the top. We're looking down on the solid. Here it is. You literally slice here, and remove all of that piece. Again, that's just the top view. That's just the top view. I'll give you another step. It was just simply, first step was to remove this channel, and I'll draw on that so you can see it. This right here is what's removed right here. That channel from above where you see nothing, this is right here. You literally cut that piece out and see nothing there. Why are you laughing now? You could ask. I don't know why you're laughing.
I don't get it. 'Cause,
Okay.
like, the way I'm drawing it is not how it's showing up on the screen.
Okay, so are you confusing the top, front, side?
I think I'm actually not visualizing it right.
What you could do, honestly, whenever you're doing this kind of work, is take something like this and consider this your starting point. And say to yourself, if I looked from the top, what would it look like? Well, I'm missing this piece right here from the top. So this little wedge, or this little rectangular piece gets sliced off because you're literally seeing through that right here. But now, Sabrina, see this line right here? This line indicates that there must be some weird difference in the shape. Well, that's because the front view tells me that I should notch out a little corner right here, and that's this little notch right here for the corner. So on the next step, what we saw, the slide looks like this in Notability. You follow what I mean?
Yeah.
So try to show it as a progression where it slowly removes pieces at a time. Okay? So we were up to here. Now take a look at that one. Why was this little piece over here removed after the top? Why was that corner piece that looks like a little hollow cube right here, why was this removed next? Yeah.
Maybe because of the front angle, it was like a blind spot.
Yeah, look at the front right here. See this empty spot Nico's talking about? Very good. This empty spot here shows that if you're looking from this angle, you should see nothing right here. So where I see, I'll use red. Where I see this right here, it's this right here. Okay? So I'm doing this one step at a time, you notice, right? So that's why I said to you, a lot of you had like a shape. I said, all right, good. Now start erasing, start adding stuff, start removing pieces. So you have to like kind of build the shape as you go through it. Again, the top view, so you can see what I was referring to earlier. I'll do that in blue. Is this in blue. So that's what's in blue from the top. Again, think about looking from the top, because what you would see, you're seeing this. And I should actually put a line right there as well. This line right here, closing that top piece, is this line right here. So this line, I'll point with a pointer so you can see it. By the way, I record all my lessons. At least I record lessons that I do. So this is all being recorded. So if you're struggling later on, I'll post this to Moodle. So yes, that it's recording. So it records the screen and it records my voice and your voices, obviously. So later on, you'll see a video of all of this going on and hear what I said. So if you're struggling over the weekend, you want to look at it again and revisit this, that might be a worthwhile thing to do. But I'll probably send you a little bit of a homework assignment to practice a couple of shapes over the weekend also. Okay, so you'll see that in an email. I'll say check the homework. If I don't put homework up at the end of the day and I put it up later for some reason, I'll let you know. I'm not going to post homework at like 10 o'clock at night and then it's due the next day and you were like, I didn't even know there was homework, because who would be checking homework at 10 o'clock at night? So regularly, your homework will be up at the end of the day or at the end of class. You'll see the homework there. But if I post it later, I'll shoot you an email so you're aware of it.
Where is your Algebra 2 videos? Because Excel is
You could just find my page, go to the math section, and look for Algebra 2 Howard. It's still visible as a course.
And what would it be under? Like,
Math, Algebra 2 Howard.
yeah, but like
Videos?
the certain folder, yeah.
So I have like, this different branches. It just says Mr. Howell's videos. And it's very self-explanatory. Yeah. There are videos from class and Mr. Howell's videos. Mr. Howell's videos are much shorter. Videos from class are longer for a period of time.
So that's Mr. Howell's videos.
That's which one.
Okay.
Yes, okay.
Can you look at the first one? The first
Yeah.
one?
Sure. So next step right here, where that corner was notched out. Okay? It's progressional. It's one step at a time. It's not always easy to see right away.
I'm having a hard time forming that then with like drawing it out. Like, can you tell me about basically format like the way it is?
Sure. So you're talking about
The middle part.
this piece right here that's missing?
Yeah.
Yeah. So what you're gonna do? You guys notice that on your original? Your original looks like this. Let me go back to that. Up for now, and let you keep going. This is how far we showed. There we go. It's not done yet though at this point. Okay, it's not done yet at this point. Okay, so now let's see. Actually, it might be done at this point, right? Let's look at the side view.
The top.
What do you got from the top that looks different?
Isn't there supposed to be like
So this is going to be removed in a minute. Yeah, sorry. This will be gone.
oh, no, it's in the
I think we're good at this point. Try to look. You tell me, ready? See side? Everybody look here, please. See side? We look from the side here. So looking from this angle, I see a rectangle, another rectangle. That's these two. I see another rectangle here. That's this guy. So from the side view, I kind of have everything already. Let me remove that because I see confused looks. Here. That's why that first thing I said today was important. This is front view. This is side view. And this is top view. So check all of your dimensions, check all of your orientations. From the side, it works. From the front, I'm looking at it. Oh, it works. I've got rectangle, rectangle. Odd looking shape, odd looking shape. From the top, I've got what looks like that same odd looking shape on the top here. I've got an L shape, and this rectangle is this piece right here. So as I progress through the solid, I need to move or remove little pieces of it. Okay. Again, this is harder than actually doing it in CAD. So if you're like, oh my God, I'm never going to do well in this course, don't worry about this as much. After this lesson today, after you practice a little homework, you're going to take a quiz next week, we're not going to be really revisiting drafting much. It's going to be all done on the computer. Okay? Let's try the next one so you can. No front view. So what does that mean to you? If there's no front view, what saying. There's no front view, Julie. You can stand at it. That's fine. Okay, I like that. No, not two-dimensional. Good idea.
It'd be like I don't know the word for it, but like if it's inclined, then it'd be like half a triangle on one side and a rectangle, and another half a triangle on the other side, like a pyramid.
Okay, but even easier than that. I know what you're saying for sure. He's trying to envision the shapes that will come from the side.
There's no front view.
Mm-hmm.
It's like, what's the reasoning for that? That's
Yeah.
supposed to include that.
Okay. If it's not given, you probably don't need it. Have it. You always have a front, side, top. But you don't need it to adjust your shape. Okay? Again, if you're not given one of the three views, you don't need it to adjust your shape. So again, you could take a look at this one. I could show you the next so you can see the progression of it. We take out one piece, we take out the other piece, and this is the final shape. This is a pretty easy one actually, but only removing the two side pieces from it to get that shape. Again, people, listen, check your email if I give you homework. Homework we posted on Moodle, but I'll shoot you an email to let you know that you drew up homework if I decide to assign you. Okay, next class, when you come in, what do you do right away? I'll do right away when you get in. Okay? Again, when you get into the CAD portion, you can leave your laptops where they are. I'll shut them down after school. Have a good day, guys. I hope you like this course. I promise we'll get into the computer design piece as we progress through. I'll be after school today. Let me close that. Okay. Well, you want that, you'll probably use your old iPad backup image to put on the new one, right? Probably redo it. So once you do that, let me know. Because for now, just take that in there. Okay? Because it's a syllabus so long, sure. Guys, have a good day. You're welcome. You're welcome. Have a good day, guys.
This is for CAD, right?
This is for CAD. You are correct, sir. Any seat is fine for you. Yeah, we're actually, we didn't even have time to get to the computer portion of it yet today. I set them up because I thought we'd get there. But we didn't actually have time for it anyway. So it doesn't matter where you sit today. But try not to be in the back. You don't need to be. I prefer the first two rows unless you need those seats filled. No.